Hey everyone, welcome back. In this video we are going to be setting up our background and getting our camera to follow our player. Also we're going to keep our player inside of our play area. So let's set up that play area. Inside of my art here, there's an image called grid. I'm just going to grab that and throw it into my hierarchy, and that's going to pop up right there. And what I want to do is I want to set up how large my play area is going to be. Using the sprite renderer, I'm going to change the draw mode from simple to tiled. I'm going to set the width and height of that grid tile to 24 by 16. That'll give us a little bit larger of an area than the camera, and that's plenty of space for us to play our game. I also want to add a border around this grid as well so we can see where the edge of our play area is. So there is a border inside of art, and I'm going to drag that as a child of my grid. Now, there is something we can do here in that for that color for the grid and the border, we can play with those a little bit. These are just white, and the fact that they are white means that if we change the color, then we can change the color of that grid. So if this to me seems a little too bright for what I want, so I want to tone it down some. So I can bring that value down, and also I'm going to change the hue a little bit to more, just add a little bit of a blue tinge to it. I'm going to do the same thing on my border. For that color, I want to make it kind of a brighter blue, somewhere up like that. The actual grid isn't too oppressive. It won't get in the way of us playing the game, but then the border is very clear. And then we can use the size of that grid to kind of lock us into our play area. But I want to use that size in multiple areas, so I need to store it in another place. A good place for that would be a game manager. So in my hierarchy, I'm going to create an empty game object and call it game manager. And just out of habit, I'm going to reset the transformations on that, and I'll add a game manager script to that game object. And I'll go ahead and add that to my scripts folder. There we go. And I'll go ahead and open that up. Okay, the first thing I want to do is make this game manager a singleton. Making this script into a singleton means that I can access it from anywhere without having to go find a game object or get a component or anything like that. So we start that by declaring a public static, then the name of the class, which is game manager, and then I give it a name, which is usually instance. And then to really make this work, I'm going to clear out these methods and I'm going to write my own. So in the awake method, I'm going to say if instance is null, if it's not set to anything. Then I'll say that instance is this game object. And then we're going to check if instance is not null, but if instance is not equal to this, then we're going to destroy the game object. So basically, if instance isn't anything, then we'll set it to this game object. Then say if there's another one, if there's something else that has a game manager on it, and it's doing its check, and it says, oh hey, it's not null, so it's going to pass that. And then if it's not this game object, then go ahead and destroy it. So then we'll only ever have one game object that has a game manager script on it. Then now I can start setting up my play area and the size and the bounds of that. So under that public static game manager, I'm going to set up a public game object for my play area. I will have to assign this in the inspector. And then I'll also set up a public vector2 for my screen bounds. And then also at the end of awake, I'll go ahead and assign what screen bounds are. They are equal to the play area dot, we got to get the component. We're going to get that sprite renderer. There we go. We're going to get its size. And let's go ahead and save that. Then what I can do is I can tell my player movement to stay inside of those screen bounds. So switching over to the player movement script, down at the end of fixed update, I want to say that transform.position is equal to a new vector2. I'm going to format this in a way that hopefully everything gets on the screen or stays on the screen. So inside of this vector2, there has to be an x and a y value. I'm going to format those so that they are on their own individual lines. And hopefully, obviously, x and y, they don't exist. So this is just pseudocode that I'm writing to kind of help me and help you understand what I'm doing here. So instead of x, that's going to be the entire x value of what I'm going to clamp this value to. So I'm going to use mathf.clamp, and clamp says I have to give it the value that I'm clamping, and then the minimum and maximum values that that value can be. So the value I am clamping here is the x value, so transform.position.x, then a comma, and I'm going to set it equal to my negative, then that screen bounds. So I can call the game manager .instance .screen bounds.x. And then the maximum value is then just, I'm going to copy that whole line there, the positive game manager instance screen bounds.x. And that will need a closing parentheses for that clamp. Similarly, the y is going to, actually, I'm going to copy all this again, that entire line, because that's a lot to write. Only this time I am clamping the y position to the screen bounds, negative screen bounds.y, and positive screen bounds.y. And let's go ahead and save, and we'll go test this out. Again, in my game manager, I have to tell it what the play area is, and that's the grid. So I can grab the grid, drag that over there. Let me hit play. There's actually a couple things I'm testing here. I'm going to see if my screen bounds works. I'm going to come and run over, and I'm getting too far out of my screen here. I can go way too far. But eventually, I will stop. So I do stop there, and it kind of kicks me back. That's interesting. And the same thing, if I get too far over here, I stop there. What's happening is I can go the entire, from the center, I can go the entire length of my play area from the center over. So I want to go back and divide in my game manager. The screen bounds display area, I want to divide that size by 2. And we'll try again. So now here I can see in my play area up here, I get to the very end and I can stop. Now, my problem with this is that my player, I'm on top of that border, and I don't want that. I want to bring him in just a little bit. Again, back in my script, on the player movement script, I want to adjust these values here. And I want to use my player game object to do it. So I have a reference to the rigid body. I also want to get a reference to the collider. So I'll set up another component reference for a collider 2D. It doesn't matter which one it is. I'll just call that call. And I also want to set up a vector2 for my object size. In start, I'll assign that collider 2D. And then still in start, I'll set object size equal to the collider.bounds dot size. And then back in my clamping, I will amend these values. I'll still go from my negative greenbounds.x, but I want to add my object size.x, and from the maximum, I want to subtract my object size.x. And similarly for y, I'll add object size.y to the minimum and subtract the object size.y from the maximum. Lots of iterating and lots of testing. All right, so now I can only go up to the corners of my boundary. I can't get over anymore. All right, but now the camera's not following us. So if I was actually playing the game, I could leave off and I can't see this border. So let's get the camera to follow us. Let's make on the camera, the main camera, let's make a camera controller script. Make a new script called camera controller. Organize my project window here. And we'll open that up. For this camera, we'll need a transform. This is a variable with a capital T for my target. I need a vector 3 called velocity. We're going to initialize that at vector3.0. We're also going to need a public vector 3 for our offset. And then we go down. Let's set up a range between 0 and 1. Doing stuff in brackets like this at the top of a script or before a variable changes how it shows up in the inspector. So now I can have a public float for smooth time. And then the inspector, we can that gives us a slider, and we can actually also still type in numbers, anything between 0 and 1. So we can lock that in between those two numbers. Inside of awake. So I'm changing start to awake. Set my target equal to, I'm going to use a game object dot find game object with tag, and we'll find our player. We'll find his transform. And then we have update. We've used fixed update. There's also a late update. So these also happen every frame, but it happens after the regular update. So this is a perfect thing to use like for camera controls and things like that. I'm going to set a vector 3 for my target position. That's going to equal the target dot position plus the offset. And we'll set that offset also in the inspector. Then we'll tell our transform dot position of the camera. We'll set it equal to a vector 3 dot smooth damp. This is a method that helps to move stuff around smoothly. And again, if we look at some of these notes, we need the current position, the target of where we're going, a reference of velocity, and then a float of smooth time. So where we are is, or what we are moving is our transform dot position. We're moving toward the target position. We're going to reference our velocity, and let's save that and go test it out. All right, so if we just jump in and play, all of our stuff goes away. And that's because there is no offset. And so our camera jumped to the position of our player. And the camera can only see things that are actually in front of it. If they're on the same value, we can't see it. Let me back out on that camera controller. That offset, I want to set it to that -10. The Z is -10, just like we did for our aiming. So in my camera controller, I set that offset Z to -10. And then this smooth time, well, let's see what happens with it. Let's test and we'll show you around. So now my camera follows along. I can only get to those boundaries, but it's just following along. Like there's nothing fancy about it. But if I increase that smooth time, get something a little cooler. All right, so yeah, increasing that smooth time kind of gives you a little bit. It kind of makes the camera lag behind a little bit. The camera has to catch up to us. So I'm liking that pretty good. So if you're cool with this, then we can be done with this video. I'm going to go a little bit more, and I'm also going to lock my camera into an area. So if I'm up in this corner, like I really don't want my camera to show 3/4 of a blank screen. So I'm going to do a little more to the camera controller. This is completely optional, but I think it adds a little bit of polish to the game. So still in my camera controller, just very similar to the player movement script, how we had to get the size of the player and clamp those positions like that. In the camera, I'm going to come and I'm going to set up a vector 2 of my cam size. And then in awake, I'm going to say my cam size equals a new vector 2. The x value is going to be from the camera.main.aspect. That guy gives you the aspect ratio, which is the width divided by the height of the camera. And I'm going to multiply that by the camera.main.orthographic size. That orthographic size is the camera's half size when in orthographic mode. That gives me an actual like world number for that, not just pixels. And then the y value for this vector 2 is just going to be the orthographic size here. So I'm going to copy that, paste it again, and then let's add my semicolon. Additionally, before that semicolon, I actually want to multiply this by like 0.75 f. Interestingly enough, multiplying by a fraction makes it larger. And then what I'm going to do is save myself a little bit of time. From my player movement, I am just going to copy the clamp that we did here. Let's copy that. And at the end of my late update, I will paste that in. I'm going to get some errors here because I need to swap the names of these things. So instead of object size, I have a cam size. And everywhere I have that error where it's saying object size doesn't exist, I'm going to replace it with a cam size. And I'll save that and head back over and test one more time. So hopefully I can get, oops. Yeah, one more thing. So when I clamp with this vector 2, it cuts off and makes the z be a 0 again. But I also need to swap that clamping to a vector 3, and at the end over here, add in that z value, which is, I'm just going to throw back in transform.position dot z. All right. All right, so now my camera also stops, and the camera doesn't follow all the way to the corner. So as my player gets away from those corners and the camera starts moving again, then the camera stops. The player can still move within those areas too. Then my dampening fell off. So now it's a little bit cooler. All right, so that's the end of that. In the next video, we will go back, create some more enemies, and we'll move on from there.